Hello, Algebra 2 folks, and welcome to graphing sine and cosine functions. So sine and cosine functions are all around us. Waves, tsunamis, sound waves are cosine and sine waves. They are truly something that is a real world application. And so today we're going to spend some time graphing them by hand. And before we do that, we're going to take a look at what we did yesterday with the Spaghetti Lab. So what you did yesterday is half of you figured out what a sine wave looks like, and that's the parent function of the sine wave, and half of you did the cosine wave, and that's the parent function of the cosine wave. What we're going to do today is we're going to change the parent function with our translations and transformations and shifting that we've done in the past. So be prepared for that. But when we looked at the parent function of the sine wave, we started at 0, 0, and the graph got bigger until it hit 1, because remember we were using unit circle, and the unit circle has a radius of 1. And then we would come back down, goes down to -1, and then back up to 360. So that is the complete cycle that we graphed yesterday, one complete cycle of the sine wave. And if we were to draw arrows and talk about domain and range, domain of the parent would be x such that x equals all reals, because this will go on forever in the x direction. If we were going to talk about the range, we would say the range is from -1 to 1. Now, if we want to use interval notation, we would say -infinity to infinity. And if we wanted to use interval notation for the range, we would say -1 to 1 using brackets, because those numbers are included. Okay? And then for the cosine parent function, we started up at 1, went down, skipped the 90, remember, because you can't find a distance at 90 and 270, and then back up, and that's how long it took us to complete a cycle from 0 to 360. Now, its domain, is the same, -infinity to infinity, and its range is also from 1 to -1 to 1. So the domain and range for both of these graphs, parent functions, are the same. Okay, but the big idea here is that sine starts at 0, 0, and cosine starts at 0, 1, or the high point. And this would be called the midpoint, and this would be called the highest point. Okay, because that's going to change based on the amplitude, and we'll talk about those vocabulary words in a second here. All right, so those are the parent functions, and that's what you did. Now let's go ahead and talk about some vocabulary. A cycle of a periodic or repeating function is a portion of the graph of the function from one point on the graph to the point at which the graph starts repeating itself. So if you want to look at this graph, the point at which it starts to the point at which it starts repeating itself, that is a cycle. Okay? It's also called a period. A period is the number of degrees it takes to complete that one cycle. So the cycle is where does it start over again? A period is how many degrees did it take to start over again? And when we did that Spaghetti Lab yesterday, we did 360 degrees, and that's how long it took to repeat itself. Okay? And the distance to which the sine or cosine graph rises or falls above or below the x-axis, and sometimes it's not the x-axis, but sometimes it's called the midline. So we want to keep that in mind, that if we have some vertical shifting, that it's not always based on the x-axis, but also the midline, is called the amplitude. So the amplitude is that distance from the midline, or in this case, with a parent function, it's the x-axis. Okay, so again, a cycle is the starting to where it repeats. The period is how many degrees it takes to complete the one cycle. And the amplitude is the distance that it rises and falls above the x-axis or midline if we have transformations happening. All right, so we need to be able to find the amplitude, the period, and the increment of each graph. The amplitude is always based on the number in front of the sine or cosine graph. And remember, that is our stretching or compressing, and it's always the absolute value of that number. So if it's -5, the amplitude is 5. The period, how long it takes, or the cycle, remember it's where it starts and stops. The period is the degrees or the radians it takes to repeat itself, is always 2 pi divided by b. Now, the period is always going to be 2 pi in the parent function because the value in front of x is always 1. But if we change that to another number, we have to take that in consideration. So 2 pi divided by b is our period. And then the increment is what we're going to put on the x-axis, okay, and how we are going to label our x-axis. And that increment is found by taking the period divided by 4. Okay, so that's period divided by 4, or 1/4 times the period. All right, so here we go. We're going to graph 2 of these graphs. Make sure that you write these down in your notebook so that we have a couple of examples. All right, so here we go. Y equals 2 times sine of x. The 2 is the amplitude. Okay, that's our A. So the absolute value of 2 is 2. Our period is 2 pi over b, and in this case our b is equal to 1. So 2 pi divided by 1 is obviously 2 pi. So it's going to take 2 pi to repeat itself. And then the increment that we're going to put on the x-axis is 2 pi over 4, which is 1/2 pi. All right, so let's go ahead and graph our graph here. Okay, so here's our x and y axes. Make sure that you're labeling your x and y axes so you know which one's which. We are going to draw a midline on the x-axis in red. Okay, and the reason why we're going to do that is because remember when I said we could have vertical shifts up and down? When we change our midline, by doing that, we will have some difficulty graphing our graphs if we're not showing that. So right now we don't have any vertical shifting, but I want you to know that our midline is the x-axis. And I always do that in red. And then our amplitude is in blue. So we're going to go up 2, okay, and down 2. Now, obviously you're graphing these on your own, so this distance should be the same above as below. I'm not going to take out a ruler and, you know, make sure that they're exact, but they should be pretty close. And then we always draw our high point and label it what we want. So this is up 2 and then down 2. No, they're not quite straight, but pretty close. And then -2 is how far down we're going to go. Okay, and then we're going to put our increments on there. Our increments are going to be spread out about the same amount. So this is 0, then this would be 1/2 pi, 2/2 pi, which is pi, 3/2 pi, and 4/2 pi, which is 2 pi. So it takes 2 pi to complete a cycle. When we graph these sine and cosine functions, I always make you do 2 cycles. So I'm just going to go on the other side of the x-axis because it's just as easy to do the cycle on the left side of the x-axis. -pi, -3/2 pi, and -2 pi. If you want to do your cycle over here, I'm completely fine with that, but it just gives me, I have more room on my sheet of paper if I do it on both sides of the y-axis. Okay, now we are going to plot our points. Now this is where our points are really important. Where do I put my points? Well, I always use the midline for the middle, and then I always use the high ends for the top points and the bottom points, okay? So we're going to talk about a sine graph. Sine graphs, we talked about those. Those start in the midline, okay? So they start midline at 0, 0. It's going to start. Then we go 1 increment to the right, and it's going to go up. just like the parent function. Okay, then one increment over down to the midline, one increment over down to the bottom amplitude line, then back up to the midline. And then that would be one cycle. Okay, we're going to do 2 cycles so you can see as my graph goes, as I'm going to the midline, I'm going to go back down to the bottom amplitude, back to the midline, back up to the top, then back to the midline. Okay, and notice that I'm doing curves and I'm not passing my amplitudes. Don't cross those amplitudes or I'll count it wrong. The domain, we talked about that with the parent function, is all rails. So it's all rails here as well. So negative infinity to infinity. And then the range for this one is not 1 to 1 or negative 1 to 1, it's negative 2 to 2. So negative 2 is less than or equal to y, which is less than or equal to 2, which is negative 2 to 2 inclusive if you want to do interval notation. I'll accept set notation or interval notation. All right, so that is the graph of an amplitude change for sine. Okay, now let's do cosine. The amplitude for this one, well, if there isn't a number out in front, it's a 1. So the absolute value of 1 is 1. The period change is 2 pi over, oh, now we have a new b. This is our b value. So it's 2 pi over pi. 2 pi divided by pi is 2. Okay, and then our increment is going to be 2 divided by 4, which is 1/2. So it's going to take 2 in order for our cycle to repeat, and our increments are going to be in 1/2 units. So we're going to draw our x and y axes. Y, x, again, labeling everything. The midline is our x-axis because we don't have any vertical shifts yet. Those are coming. And then our amplitude this time is 1. So I'm going to go up 1. You can use a ruler. It'll be easier. And I'm going to go down negative 1. Notice these are about the same distance. Okay, now our amplitude, or excuse me, our increment is what I need to draw now. Label this 1/2, 2 halves, 3 halves, and 4 halves. Then I'm going to go to the left side of the y-axis to do my other cycle. Always labeling my increments. Okay, and now I am going to graph this function. Now this is a cosine function, so we have to be careful because with sine function we started at 0, 0, but cosine functions start high. So you go to your highest amplitude. That's where your first point starts in the middle at 0, 1 here. If our amplitude was 3, then we would do 0, 3. So we're going to start high. We go to our next increment. We go to the midline. Down below, back to midline, back up. Okay, the left side cycle, back down to the midline, down to the bottom amplitude, back up to the midline, back up to the top amplitude. Now when we're graphing these, we don't go through the point and past the amplitude. We have to curve it so it goes down and through those points. Okay, and then we have the arrows coming back down. So don't make your arrow go up here because I will count that wrong. All right, and then make sure it's curved. If you're drawing these, they're going to be wrong because these are curves. They're waves. So think of them in terms of a wave like a W. Okay, and this one almost looks like a W. The domain is x such that x equals all rails, just like the parent function. And that would be negative infinity to infinity if you want to do that. And then the range for this one is low to high, which is negative 1 to 1. And in interval notation, negative 1 to 1 would also be acceptable. All right, so we have graphed some cosine and sine waves. and make sure that you know the difference between cosine starting in the midline and, or excuse me, sine starting in the midline and cosine starting high, and drawing them as W's and wavy so they look like waves. All right, thank you for taking good notes, and we'll be back to practice these in the days to come.